Welcome to This Explainer. Today, we're taking a structured, step-by-step look at exactly how to control hardware using the Arduino Uno R4 and the Motor Shield Rev3. If you're a beginner wanting to dive into robotics or automation, you are in the exact right place. We're going to take this at a nice, steady pace, working our way from the most basic concepts all the way to writing the actual code and troubleshooting your setup. So, let's get started.
Here is our roadmap for today's explainer. We'll cover 1. Basic motor concepts, 2. External power safety, 3. Pin layout meanings, 4. Setup and programming, 5. Motor current sensing, and finally, 6. Quick troubleshooting.
All right, Section 1, Basic Motor Concepts. Let's talk about how we actually control speed. To control a motor's speed, we use something called PWM, or pulse width modulation. Now, I know that sounds incredibly technical, but honestly, it's really simple. Just imagine a standard light switch in your house and you want to dim the light. If you flick that switch on and off incredibly fast, say 100 times a second, the light is going to look dimmer to your eye, right? Because it's only getting power a fraction of the time. Well, that is exactly what PWM does for our motors. The Arduino is just rapidly switching the power on and off. A value of 0 means the power is always off, so your motor stops completely. A value of 255 means the power is always on, giving you full speed. And any number in between? That gives you precise, smooth speed control.
Moving right along to Section 2, External Power Safety. This is absolutely crucial for protecting your hardware.
So the big takeaway here is this. Motors are basically power-hungry little beasts. They draw way more current than a standard USB connection can safely provide. If you try to run your motors straight from your laptop's USB port, you really risk damaging your Arduino or even your computer. You definitely don't want that. The golden rule here is to use a 6 to 12 volt external power supply, something like a battery pack with two 1865 lithium cells, and wire that directly into the power screw terminals on the motor shield itself. The brilliant part of this design is that the delicate logic brain of the Arduino board will just keep humming along perfectly safely on that 5 volt USB power, totally isolated from the heavy lifting of the motor power.
Section 3, Pin layout meaning. Let's map out exactly what is on this motor shield. What's really neat about this slide is how beautifully everything lines up. The Motor Shield Rev3 is built around the L298P dual full bridge driver, which basically means it gives you independent control over two totally separate motors. And because the Uno R4 shares the classic Uno header layout, this shield plugs straight onto your board, zero extra messy wiring required. Notice how it's divided into channel A and channel B. For each channel, you get a specific digital pin dedicated to direction, so making it spin forward or backward. You have a pin for PWM to control your speed. You've got a brake pin to instantly lock the motor shaft, and finally, an analog pin for current sensing. It is just a wonderfully elegant and organized system.
All right, Section 4, Setup and Programming. Let's get things moving. Getting the software ready is an absolute breeze. Just hook up your Uno R4 via your USB-C cable and fire up the Arduino IDE. Over in the Library Manager on the left sidebar, simply search for DIYables DC Motor and hit install. The best part? This library is entirely self-contained. There are no annoying extra dependencies you have to track down. Literally, everything you need is packed right into that single quick install.
And as you'll see here, the actual code is brilliantly simple. You don't have to write hundreds of lines to get your motors moving. This minimal skeleton really just relies on 3 main commands. First up, motor.begin configures all your direction, PWM, and brake pins automatically in the background. Then, motor.run takes 2 simple instructions, the direction, like motor_forward, and the speed, say 100 out of that 255 maximum we talked about earlier. Finally, when you need to stop, motor.brake safely drops the speed down to 0 and engages the electronic lock. It really is that straightforward.
Section 5, Motor Current Sensing. This is how we keep a close eye on our hardware's health.
As we saw on our pin layout a moment ago, the Motor Shield uses those analog pins to monitor power. Pin A0 specifically reports the real-time current being drawn by whatever motor is connected to channel A, and pin A1 does the exact same job for channel B. Now, why does this matter to us? Well, imagine your newly built robot accidentally drives into a wall and gets stuck. The motors are going to strain and start drawing massive amounts of current. By reading these analog pins, your code can actually detect that power spike and shut the motors off before anything burns out.
And here is a really fantastic detail specific to the Uno R4. Older Arduino boards used a 10-bit analog to digital converter, which maxed out at a reading of 1023. But the Uno R4, it features a powerful Renesas chip with a 14-bit ADC. That means your raw current sensing reading now goes all the way up to 16,383. This gives you an incredibly high level of precision when you're monitoring exactly how hard those motors are working.
Finally, Section 6, Quick Troubleshooting. Let's fix some common beginner hiccups.
This right here is probably the most common question I see from beginners. What if my motor just isn't spinning, or it feels super weak? You've plugged everything in, uploaded the code, and nothing. Or maybe it just sits there and softly hums.
Don't panic, let's just methodically run through the fixes. First, double-check your physical connections. Make sure the bare wires are actually clamped tightly down in those screw terminals, not just sitting loosely. Next, check your code. Did you tell the software to run channel A but physically plugged the motor into channel B? Happens all the time. Here's a great pro tip. If the motor is just humming but not spinning, bump up your PWM speed value. Motors have physical inertia. A very low speed value simply might not have enough torque to get those internal magnets spinning from a dead stop. And of course, always check your external battery. Make sure it's fully charged and that you haven't swapped the positive and negative polarities.
Now, what if everything works perfectly, but your robot is driving backward instead of forward? You actually have two completely valid ways to fix this. You can do a quick hardware fix by grabbing a screwdriver and just swapping the two motor wires at the screw terminal. Or you can do a software fix by changing the motor_forward command to motor_backward right in your Arduino code. Both work perfectly, so just pick whichever solution is easiest for you in the moment.
And there you have it. We've covered the concepts, the safety rules, the code, and exactly how to troubleshoot. You now have the complete beginner's blueprint for using the Motor Shield Rev3. The only question left is the most exciting one. Now that you know how to safely bring hardware to life, what are you going to build next?